Welcome to Week of Geometry Day 2, where we are talking about area. You might have done area before, you should have done area before you got to 7th grade, but we're going to be talking about how to find the area of some kind of complex figures. Up here is a box for us to include some notes about our area formulas. And the first thing that we need to write down is that area always equals some form of base times height. I should say some form. Area is always going to equal some form of base times height. Now you have already done this before, but usually we just call it something different. Usually, let's say if we have a rectangle, and you want to find the area of that rectangle, usually we'd say we do length times width, which is correct, but this is just using kind of a different term and calling the bottom of that shape the base, and then however tall that object is, the height. It's the same as length times width, but it says base times height, and that will kind of help us with some other shapes that we're doing as well, where it's not just length and width. So, area is base times height. Now let's see how that kind of works with some weird looking shapes. Here we have a triangle. I know it's got a base, I know it's got a height, but this is a triangle. It's not this rectangle that we have up here. But actually, I could easily turn this triangle into a rectangle by just kind of adding some dotted lines here, adding some dotted lines there. So this triangle is now half of the rectangle that I have. Well, let's figure out the area of the rectangle to start with. The base is 12, the height is 5, so we can do 12 times 5, because that's our base, times our height, and 12 times 5 equals 60. So the area of this rectangle would equal 60. But we're not trying to find the area of the rectangle, we just want to know the area of this triangle right here. Well, since this triangle is half of the rectangle, I'm going to divide the area of the rectangle by 2 and get 30. Now, whenever I find the area, I always want to write what my units are. Since it doesn't tell us any units, I'm just going to write units and then squared. Area is always squared. We talked about how volume is cubed. Area is squared. That means I could fit 30 squares into that triangle. And that's how we find the area of a triangle. Do base times height and divide by 2. So right here is a parallelogram. It means that these two lines are parallel and will never touch, and these two lines are parallel and will never touch. And when we have a parallelogram, it gives us the length of this part and the length of this, but it looks different than a rectangle. But if you'll notice, we can take this triangle, and if we could cut the paper, which we're not going to do, but if we cut this part of the triangle out and moved it over here, it would look something like this. This part would no longer be there, and now we have a rectangle. All we did was move that piece to the side. Well, now we know how to find the area of a rectangle. We just do base, because this would be 12, just like the top, base times the height. And 12 times 9 is 108 units squared. I could fit 108 little squares into that parallelogram right there. And that's how we find the area of a parallelogram. Third shape we've got is a trapezoid. Now trapezoids are tricky because there's one base along the bottom But along the top, the height is actually different, or the top base is different. The bottom base is 29, the top base is 13. So the way that we find the area of a trapezoid that looks like this is we're still going to do base times height, but since there's two different bases, we're going to find the average. You might not remember how to find the average, but we add those things together. 29 plus 13. And to find the average, we add them and divide by how many numbers there were. We've only got 2. So 29 plus 13 divided by 2. That'll be our base, because it's the average of the bases, times the height in this case is 15. Let's see, 29 plus 13 is 42 divided by 2 times 15. 42 divided by 2 is 21 times 15. And if you had a calculator, you could figure out that equals 315. Then, of course, we'll have our units squared. Oops, sorry, I didn't realize I was off the paper there. 315 units squared. 315 squares could fit inside that shape. Now, last but not least, we get to a circle. Now, circles are special circumstances. When we have circles, it is actually not going to be base times height, because if you noticed, there's not really a base, and I mean, there is kind of a height, but what are you going to do with no base? So let's go back up to the top where we had some notes. This is going to be our special case. Circles. Circles are a special circumstance. The area of a circle, which we call A, equals pi r squared. Now, we've used these things a little bit before, but if you can't remember, pi, that little symbol right there, is approximately 3.14. That's why I did that kind of equal sign. Pi is about 3.14. R stands for radius. So R stands for radius. And the radius of a circle is the distance between the center of the circle and the edge of a circle. That's our radius right there. So it only goes halfway through the circle. It doesn't go all the way across. But you do pi times the radius squared. Now let's go ahead and take a look back at that circle we had. So I know that I need to do pi times the radius. In this case, it's telling us that the entire way across a circle is 8. But I know our radius is only halfway. So if the whole thing is 8, half of 8 is only going to be 4. So I know my radius is 4. And I know I'm supposed to square it. Now when we do squared, 4 squared is 4 times 4. So I know that's going to be 16. Pi times 16. Once we reach this point, we have two options. Some mathematicians leave their answer like this, but they put the number in front. They do 16 pi. They got rid of the multiplication sign, but since it's next to each other, it still means multiplication. 16 times pi, and they'll say 16 pi units squared, and they leave it like that. Or what other mathematicians do is they actually plug into their calculator 16 times, and then they estimate, do 3.14. And so if we did on our calculators 16 times pi, we would get 50.24 units squared. So some mathematicians like to leave it 16 times pi. Others like to multiply it out and estimate. And that's how we find the area of those four figures.